Welcome everyone to the first session of the problem solving corner for the course of Principles of Physics 1, where we are basically at this stage emphasizing on introductory mechanics. So the first problem is on vectors. It says that there are two vectors that are given by these expressions here. A equals 5x minus y plus 2z, x hat minus y hat plus 2z hat. This x, y, and z are no variables, but they are the unit vectors corresponding to the x direction, y direction, and z direction respectively. Here we have a second vector, which is minus 3x hat plus 4z hat. Okay, so the first question is about finding the angle between the two vectors, and this is interesting because in order to find out the angle, we'll need to employ the dot product between the two vectors, right? Basically on three stages. So the general mechanism is to do the dot product, and then we'll get A dot B equals A, which is the magnitude of A, B, which is the magnitude of B, times the cosine of alpha, where alpha is the angle between A and B. So angle between A and B. So not only do we have to find out the A dot B, but we'll also have to find out A and B, where we also will need the dot product. So A, which is basically the magnitude of A, is given by this formula here, square root of A dot A. Similarly for B, we have square root of B vector dot B vector. So if we are able to find out these three dot products, then we are done. Plug them into this formula and then find out alpha. So that's our general mechanism here. So here we have the A vector and B vector. So the magnitude of A vector is going to be square root of A dot A. And this is simply the square root of 5 squared plus negative 1 squared plus 2 squared. And then since we haven't used any units, so you don't have to worry about units in this case, so we have 25 plus 1 plus 4, and then this is just simply square root of 30. So that's the magnitude of A. So the magnitude of A is going to be square root of 30. What about the magnitude of B? Well, the magnitude of B is going to be square root of B dot B, which is equal to square root negative 3 squared plus 4 squared, and that is of course 9 plus 16, which is square root of 25, which is 5. So B equals 5. Finally, we'll have to find out A dot B, which is going to be 5 times negative 3, and then this one doesn't have any coefficient of y hat, so that is actually 0. So we have plus negative 1 times 0, and then plus 2 times 4. And so this is going to be negative 15 plus 8, which is negative 7. So then we've got A equals square root of 30, and then B equals 5. So if we do plug that in our definition of dot product, we have AB cosine of alpha, and then cosine of alpha is going to be -7 in the numerator, and A times B, which is 5√30. And so the angle between them is going to be alpha equals cosine inverse -7 divided by 5√30, which is approximately 105 degrees. So that was the first part of the problem. The second part says find a vector that is perpendicular to the two vectors. So it doesn't say in which order we should consider the two vectors, because in case of finding the perpendicular, we have to take the cross product between the two vectors, and in case of the cross product, the order matters. So whether we take A cross B or B cross A, it doesn't matter in this case because they haven't specified a particular order. However, if they ask you to find out A cross B, then the order is fixed and there are no more questions. So this vector, this A cross B, would produce a vector C, which is perpendicular to the two vectors that are given here. And this vector is found out by taking the cross product between the two, and the cross product in Cartesian coordinate is given by this formula, which is this completely antisymmetric object called the determinant, written as follows. It's just a computational device. Fortunately, we have the fact that it has such a nice structure, which is a well-known structure of the determinant. And so in the middle row, we write the components of A. And for that, we have 5, -1, 2. And in the last row, we have the components of B. So we write -3, 0, and 4. So we have to expand it by this row here. So first we have x hat, and then we multiply -1 with 4, and then -2 times 0. So -1 times 4 gives us -4, and -2 times 0 gives us 0. Plus y hat. So in that case, we have -3 times 2, which is -6, and then -5 times 4, which is 20. And then we have z hat, where we first take 5 times 0, which is 0, and then -1 times -3, which is +3. But we have a negative sign beforehand, so it's just 0 minus 3. So if you simplify it, what do you get? You get C, the perpendicular vector, equals -4x hat, -26 y hat, -3z hat. And this gives us the perpendicular vector to the arrows. This question, however, might be rephrased as find the perpendicular direction to the plane of the two vectors, or find the unit vector to the perpendicular direction of these two vectors. And they would simply imply the same thing, is that find the unit vector in the direction of C. So the direction would be given by this C hat, which is given by this C vector divided by its magnitude. And the magnitude is, of course, given by -4 whole squared plus -26 whole squared plus -3 whole squared with a square root. and then you just plug them in here, and that would yield the desired answer.